H's. Those are going to have H's right there. That's fine. Okay, now the ends. Remember we said we can do those different because this end is going to have a double bond to it. So let's make that one more purplish, or whatever the color blue this is. The other ends, if we do these the way I taught you to, not the way I do it, which is in a big hurry messing it up, we would find the ends that are done. Come up a little bit here. So when you see stuff like this, boy, it kind of reminds you of the lysine, I think the amino acid is. So you start seeing the way some of these things could be constructed. This one here is going to need an H, right? So do the H, then color it in, and see the way we're correcting ourselves. We're not having to commit to the electronic structure of anything till we're darn ready. And then once we color it in, we're done with it, right? The oxygens are colored in, we're done with them. Don't have to worry about their bonds. Nitrogens, same way here. 3 bonds on a nitrogen. So once we color it in, it's got all 3 bonds. Here, it's got 3 all by itself. See, those are all bound to electronegative elements. See, that's got the methyl off it. I was able to compare this ring to that ring, and I thought, well, why is this end different? Well, this end has an H on it. This one has a methyl. That's a carbon on it. So that's a different colored one there. So maybe color that one in a little purple too, huh? Since it's next to the methyl. But see, it's a triangle. It's not the diamond, so you won't get it mixed up, even if it's that color. Over here, we're back to the regular nitrogen. 1 H on it. And we come to these guys, double bond, but it's going to have a 1 on it. It's no biggie. And this is going to be an NH2. Just color those blue, I guess, if you want. That thing didn't show me when it turned off, so naturally all the good stuff I just talked about. Nitrogens that are double bound here. There's one up here with a double bond. So see the symmetry of this? Right on the ends, nitrogen in from a nitrogen has a double bond to it. This one carries the chain on, that one doesn't. CH2s, now we're coming up to these nitrogen carbonyl. Nitrogen carbonyl. Now you got these rings, 5-membered rings with a nitrogen in them. And I was saying how these 2 nitrogens were different as I was coloring them in different shades of blue or purple. I said, oh, wait, that ring is just like this. See the brown carbons, like a benzene ring, CH1s. But then that nitrogen, I said, wait. That's blue, and this has a methyl on it instead of the proton. So I was really able to distinguish the difference on those. And what makes this so cool is that it fits in the minor groove. If you have a DNA strand that's cancerous or it's giving you trouble, this is called an antiviral. Say the virus. Virus has DNA. AT-rich portions of that, this will bind to it. So one of these days we'll draw some AT strings going along and we'll see how this could fit in there. That's where the alien's going to come in handy, because wherever it's negative, that's a possibility to do a hydrogen bond. So it must be hydrogen bonding, or what do you got? You got negative phosphates coming off the backbone. I don't think the hydrocarbons could fit in there. The minor groove, we'll have to look at what the minor groove is like. So this is Netropsin. Might be one of the first antiviral drugs that they found. I don't know the history on it. So there you go for that. Now we're going to move on. We got one. Oh, this is going to be an up and a downer here, huh? Now BetaNIN, I write everything with beta, has 3 cool portions to it. We should probably draw this sideways, I guess. It's going to have a glucose, and then it's going to have a tyrosine. Well, this will be an indole, and then a tyrosine off the end of it. So we'll draw the diamonds of a glucose out here, starting with the oxygen. So here's your oxygen's big. Go to a diamond, to a single bonded O. Let's go this way with it. Single bonded O. Oh, look at that. To another O. That's almost like a peroxide. Did I draw that right? We'll draw them right next to each other. Look at that. That's what your peroxide looks like. And that'll go into a diamond. It's going to be a benzene ring. So we'll just get some of that going there. Double bound down. Double bond. And I better keep going because I got it going good, or that's where I messed up last time by saying that, didn't I? And that'll give us a double bond to here. And then we can just single it that way. So color in the double bond part yellow. Double bond. Double bond. Insider double bond. Okay, back over here though, we're doing the sugar glucose. So from this diamond down here, we go to a diamond. Remember, 6-membered ring, but one of them is an oxygen. So diamond to here. Let's draw the diamonds. Worry about the OH later. Look ahead a little if you have to, but that's it. Call that 6, 5, 4, 3, 2, 1 in the ring. 6 carbons. That's number 6 up there. You want to get some of that out of the way. Oh, that's an OH. It's okay though, because there is 1. Well, there's going to be 2, I guess. So let's tell you what. Let's do that way. We'll put that OH there. We tried that once like that. You can do it that way if you want. This O's bigger. Big O's. Boy, peroxide in that one. So we got some OHs here now. This is going to be an OH down. It's going to be an OH up.